And welcome to today's panel discussion on printers and deposition systems. For many years, manufacturers have been seeking an alternative to the stencil printer as a method for depositing solder onto printed circuit assemblies. This panel is going to discuss the latest range of deposition systems and compare their strengths and weaknesses with stencil printing technology. Now, I've got a really interesting panel with me today. I've got one of the best experts on stencil printing, Torsten Vegelen from Asus Ekra on the end. Then we have next to him Twan Andelzy from Chiron Technologies. This is the new company startup out of the Netherlands with a new system. And then next to him we have Chris Whitfield from Europlacer, which make stencil printers. And then we have jetting systems from Mycronic, represented by Robert Halliday here. So, great panel. I hope we'll have a robust debate here. Let's get it started with the very first question, which is what are the significant advancements in jetting, screenless printing, or additive deposition technologies that now challenge traditional stencil printers in terms of accuracy, repeatability, and throughput? We'll start on this end and move this way. Okay.
Start on this end?
Yeah.
Okay, thank you first, Trevor, for arranging these panel debates.
Okay.
I think it's really great, and so we can have a chance to debate among ourselves, which is not every day, right?
Mm-hmm.
But if you look to 20 years ago, we released a jet printer here at Productronica, 2005.
I remember it well, and the headline was, what was it, 1 million dots an hour or something, and everybody said, oh my goodness, that must be faster than a stencil printer, but it wasn't.
It wasn't.
Okay.
But it's more aimed to the people who use a lot of new layouts, of course, and some other things too. And I think that since then we've done, of course, developing this technology. We have now with the third machine generation, and we have a lot of new ejector generations. So we can do everything from 1 nanoliter in one shot up to 40 nanoliters.
Yes.
Because customers want sometimes less paste, a very small fine pitch, and also a lot of them.
Well, it seems to have found its niche in as much that it's either used for prototyping or small batch, or in many cases it's get used for top-up after stencil printing, where you've got missing paste and that type of thing. So it's
correct. We have that too. But if you look to the segment that Mycronic is in, with the pick-and-place machines and so on, with the high flex, then one machine or even two machines of the jet printer can satisfy the most needs for that customer segment, actually. And we also have some examples where you have more of a capability issue, where we have the machines also on high-speed lines for doing mobile phones and stuff like that.
Okay. Chris, what is your view on the sort of deposition systems versus the stencil printing? Because you've pretty much your own stencil printing system. So, but you're also looking at some top-ups with dispensing as well.
Yeah. So obviously, like the stencil printing industry is established platform. It gives you consistent deposits. It gives you a low amount of process really knowledge to get a consistent and high volume output. It still produces a high volume, and it's probably still the most commonly used system out there. Our system has an ADU system, which is a system that allows you to add extra paste or glue to top up if required, or do prototypes as well, be it at a lower rate than jetting. It's an interesting time with some new technologies coming out, and the jetting machines becoming more established. I think from my point of view, they're still firmly in the low volume and R&D type environments, and they have a niche place, but still away from replacing the stencil printing.
Okay. All right. Okay. So let's move on to Twan. Obviously, you've just launched a new machine here today. We're seeing it for the first time, but it appears to be for the lower volumes, but there are other advantages. So maybe you want to tell us a little bit about it? Because it's new to us and it's new to much of our audience.
Yeah, thank you, Trevor. As we all know, of course, in the industry for many, many years, we are struggling with the stencil, with the compromise in the thickness, which also gives some challenges right now for the miniaturization and the fine pitch components. And that is the sweet spot from our process, where we can place any volume, any size, anywhere, and we can go very, very small. And the other thing is also, we are not limited to a design. So if you can place a very small deposit, or I would say like a very small pad to a bigger component, there's also a possibility with the technology we have.
Okay. So let's move on to Torsten. I mean, you're obviously very committed into the stencil printing side of the business, but you can obviously do the high volume. What is your view on some of these new technologies that are coming through?
You know, ASIS, or especially ACRA, was in the printing business since 50 years. So for us, it's also the 50th anniversary this year for working with printers. And we have done so many inventions on small bits and pieces and dispensing systems in the printers to give add-on value to our customers. But finally, it really remains on the still known and well-known focus process of the stencil and the step stencils, which gives them all the possibilities for the processes for small components, tall components, high volumes, low volumes, what all mixture they like to do. The race, what we're facing is, of course, speed, throughput, cycle time, and precision repeatability. And that's what we did today, that's what we did today as we introduced our new Gen S series to the audience.
Okay. I mean, certainly you're well ahead of the race in terms of speed and throughput and that type of thing. But, you know, there's the old adage that people say that 60 to 70% of the defects come from the printer. That happens mostly because of, you know, drag coming off of the stencil and things like this. So, you know, the stencil can be an issue.
Stencil can be an issue. Paste can be an issue. Humidity can be an issue. Temperature can be an issue. The human is an issue.
Right.
And if we just take the stencil off, we still have many potentials left, which has a huge influence on this 60-something%, which are named very often.
But then, do you get the same percentage of defects coming out of a deposition system? I mean, I don't know.
That's, I think, a very good question. Well, actually, we can control the environment. So that's, of course, we were looking at the same thing. So also, we were checking out, okay, what are the external obstacles or hurdles in the process, and which one we can eliminate. And that's the same with our system is all completely digital and also being offline, being programmed. So the user interface at the machine itself is very simplified due to the reason that our operators are not the ones who are changing the process at the spot. Of course, they can do this, but you want to have a solid process. So that's one of the topics.
Yeah, and I think as you rightly point out, I mean, you've been testing it so far in a controlled environment. You know, and it's a new machine. There's going to be a lot of times when you're going to send it out to somewhere that's very humid in Asia or somewhere that's very cold, and it's going to perform differently. And you've got to learn all of that yet and process all that data and you know, see where the machine really sits, to be honest.
Yeah, correct. So that's also the reason why we also can control the environment inside the machine. So on temperature, on humidity. Also we have like an overpressure in the machine, so also dust cannot come in. So we have some tips and tricks built in. Okay. We can control the environment.
Right. Okay. Chris, how do modern deposition systems perform when it comes? Oh, I was going to. No, I'll need to give that one to. In fact, I'll jump, Chris, and I'll come to you, Robert, because this is a deposition one. How do modern deposition systems perform when it comes to fine pitch and ultra miniaturized components? Are they meeting the same process capability and reliability metrics as today's high-end stencil printers?
I mean, I can answer for my system, okay? So I think when you look to some of the customers, at least what they say, is that when they want to do really, really small print with a screen printer, they use a very thin foil.
Yeah.
And this is something that they say can be have wear and so on. So that's one issue that we hear, at least. And now with the new ejector that we also released today, we have 180 micron, 1 nanoliter. So that for I think many customers that's enough. Maybe not for semicon or something like that, but for PCBA, I think this is a very good step now that we have done. And then you have the miniaturized components for the most customers actually.
Okay. Okay, Chris. So when it comes to evaluating the total cost of ownership here, because at the end of the day, it comes down to money and process. Equipment, consumables, maintenance, process yield. Where do printers really sit in this in deposition systems? I mean, how do they compare?
Yeah, I think we all know that the jetting systems are more expensive. We don't know the final price on your new product, so it'd be interesting to see. And depending on, it's very hard to compare like for like, but if you're looking at any sort of medium to large volumes, then stencil printing is still going to win, hands down, in terms of cost per print. If you're looking at low volumes, again, it depends if just jetting systems have their niche market in terms of quick turnaround and quick prototyping. It's always one thing I'd say about the printing side is interesting that in all jetting systems, we seem to throw out the window the formation of pad and the actual definition of a pad. If you look at what you get out of a stencil print machine, you get very defined pads, very constructed shape to the pads, and you have control from a process point of view. When you flip over to the jetting systems or any other dispensing system, that seems to go out the window, and we live with the deposit shape of a particle that's shot through the air. So from my point of view, you definitely lose some control there, and depending on what components are being placed or what the process is, may or may not be a disadvantage.
Right. Torsten, I mean, what's your view on the total cost of ownership argument? I mean, do you think it's still with the stencil printer hands down?
The stencil printer itself, or these materials, what we need with the stencil itself, is one of the cheapest we can do.
Yeah.
And we have a wide market of printing systems, so we are on a real good price level as well. So for the customer, they can have really good OEEs with just using stencils, step stencils. They're a little higher in price, and the technology, it's available on the market. And if you go around and you see a stencil you can get for 200 euros and less for a normal stencil, this is nothing, and you can use it for 100,000, 200,000 times, even more, if you don't change your layout. So this is peanuts what is going into the product.
Yeah, well, I mean, certainly the capital cost is a lot cheaper than the deposition systems. You do have other issues with storage. You've got to store stencils. They take up space. You've got to clean them.
Yes.
Cleaning system. So there are other costs involved there.
That's right, that's true. But you have stencils, they're just a foil, and you can store them as a foil. You don't need them in a frame. There are possibilities. And cleaning, of course, is an issue. But I'm sure you also need to clean a jet system, and you need to maintain a jet system.
Sure.
You need to clean whatever is your primary target, which is coated, where you lift off from the technology. You can't use this forever as well. Yeah. And coming back to the thin foils, like the 35 micrometers, what we have indeed in operation on customer side, what you can see here on the show, and this is like a premiere, we have inside a machine a new probe, a new sensor, where we can really see and measure what's going on with the squeegee, with the paste on a screen.
Right.
It's not as far developed that we can see it on a stencil, but especially if the stencil becomes thin, that makes really sense to maintain the quality and extend the lifetime, especially on screens.
Right.
Trevor, can I come back to what Chris said?
Yeah.
Because on the stencil side, I think, of course, if you're high volume or medium volume, you have a certain advantage, right? But on the definition of stencils and where to have the deposits, here I think actually jetting system has a big advantage. Because the user can select exactly, we of course have a library and stuff, but you can select exactly where you want the deposition to be on your pad. and this is also like a knowledge management system, so you can keep that for various different customers or paste or whatever you have. So I think we can see from the 1,000 customers or so we have that you get a really excellent result from that. That is something that is mostly within the stencil makers know-how, right? So that you will have inside the machine instead.
Okay, Tuan.
Yeah. Sorry, can get a response very shortly.
Okay.
Also getting exciting. Actually, at our booth, we made a box. We call it the paint box. And in the paint box, we put all the consumables which you can save, right? And of course, the majority, and we are indeed in the high mix, low to medium volume. But you can imagine that we have customers are having 10 changeovers a day, right? Mm-hmm. But also buying 500 stencils a year. So you can imagine it's a lot of money. But also a changeover is like 15, 20 minutes. So do the extrapolation for 1 year. And then also you can have an idea what you can save on that in terms of return on investment and cost savings.
Yeah. Well, certainly it's certainly useful for high mix environments, that's for sure. So how well do these newer systems integrate with AOI or SPI feedback loops on MES platforms and data-driven SMT lines? I mean, how does your system integrate with
yeah, we have 3 machines in one, as we say. So also we have an inspection system inside. So that means also that we do a pre-inspection on the board. So we do an inspection on the bare board,
okay,
and there we check the landscape of the board, so about the height of the solder mask, silk screen, stuff like that.
So you look at the topology of it for warpage and things like that.
Correct.
Yeah.
So we know exactly how each board makes it a unique board. So also making sure that we can have the right deposition on the right spot.
Okay.
Yeah. So that is of course for the I would say the pre-inspection of the bare board, and then afterwards we have like an SPVM, as we call it, solid paste volume metrology, and there we're doing a measurement on each volume, and that's really a differentiator I think in the industry, and of course also being used for information to the MES, to the AOI, and of course for traceability purposes.
Right.
Oh.
Okay.
I think from our standpoint, we have all the machines in the line basically, except the oven. Mm. So we have a lot of commonality and working even more to make it like a full line. So you can program all the machines in one software.
Right.
So that I think is something that is unique for Mycronic to have all of that.
Yeah, the interesting thing you did recently, Robert, was that you introduced a stencil printer. What do you call it? I mean, you already had Jettas, but you actually went back the way and brought in a stencil printer. So you obviously see the value in having both, I'm guessing.
I mean, let's just face it, it was Chris and Torsten says.
Yeah.
A lot of the things in the world are done with screen printers, right?
Yeah.
And you can have, if we have that, then we have one more process step to do, and then we can combine the advantages of both. Mm. So I think it's not a bad thing. I mean,
okay. Okay.
So.
Good. Okay. So let's look at the sort of future outlook. We'll start off with you, Torsten. I mean, do you see a realistic path where non-stencil deposition becomes the dominant solder application method in the next decade, or will it remain a niche for specialized applications?
Printing technology is around for centuries, and I think I did say the same sentence